Hello, you are welcome to today's lesson. So today's question is, for the figure 2 below, calculate the following. I, total resistance, II, circuit current, III, total power, IV, power in each resistance, and then V, voltage across each resistor. So that is the figure 2. And figure 2 is having three resistors, okay, which is connected in series. Okay, so we have R1, R2, R3 connected in series across a supply voltage of 28 volts. Okay, so R1 is what 6 ohms, R2 is what 3 ohms, R3 is what 5 ohms. All right, I hope you are ready. Okay, so let's move on with the solution. So we start with I, that is the total resistance. So since it's a series circuit, to calculate for the total resistance, which is RT, we are going to add all the resistors, okay? So we have R1 plus R2 plus R3, okay? And this is equal to what? 6 plus 3 plus 5, which is going to give us what? 14 ohms. So the total resistance, or RT, is what? 14 ohms. Okay, so let's move on with the second one, that is II. And we are to calculate for the total current. So the total current, that is IT. By Ohm's law, we know that current is proportional to the voltage and inversely proportional to resistance. Okay, so IT, which is the total current, is equal to VT over RT. That is the total voltage over the total resistance. So this is equal to what? 28 over 14. The supply voltage is for 28. And then the total resistance that we calculated for is what? 14 ohms. So we have 28 over 14. So when you divide, we are going to get what? 2 amps. So the total current, or the supply current, is equal to what? 2 amps. I hope you are following it. So let's move on to the third one, which is III. And we are to calculate for the total power. So total power PT is equal to what? IV. That is the supply current multiplying the supply voltage. Okay, so that is equal to what? 2 times 28, which will be 56 watts. So the total power, or PT, is what? 56 watts. I hope you are following it. All right, so let's move on with the next one, that is IV. And we are to calculate for the power in each resistance. Power in each resistance. All right, so when you look at the figure, I explained earlier that the resistors are connected in series. And one thing that you should remember is when you're dealing with a series circuit, the current is always common. Okay, so the supply current, which is 2 amps, is common to the circuit. The 2 amps flows through resistor R1, the same 2 amps flows through resistor R2, the same 2 amps flows through resistor R3. Okay, so the current is common. So to calculate for P1, that is the power across resistor R1, we use the formula I square R1. Okay, I square R1, and this is equal to what? 2 square times 6, which is equal to 24 watts. So P1, that is the power across resistor R1, is what? 24 watts. P2 is equal to what? I square R2, which is equal to 2 square times 3. When you multiply, we're going to get what? 12 watts. And then P3 is also equal to what? I square R3, which is 2 square times 5, which is equal to 20 watts. So P1 is what? 24 watts. P2 is what? 12 watts. And then P3 is equal to what? 20 watts. I hope you understand. All right, so let's move on with the last one, which is what? V. And we have to calculate for the voltage across each resistance. Voltage across each resistance. All right, so V1, that is voltage across resistor R1, is equal to I times R1, which is equal to what? 2 times 6. And that is going to give us what? 12 volts. So V2, which is the voltage across resistor R2, is also equal to what? I times R2. And that is equal to 2 times 3, which is what? 6 volts. And then V3, that is the voltage across resistor R3, is equal to I times R3, which is equal to 2 times 5, which will give us 10 volts. So V1, that is the voltage across R1, is 12 volts. V2, the voltage across R2 is 6 volts. And then V3, the voltage across R3 is 10 volts. I hope you understand. Please don't forget to subscribe to the channel, okay? Don't forget to subscribe to the channel. And share the videos also with your friends, okay? Share the videos with your friends. Thank you so much.